So this is kind of an extra section that doesn't really have its own section number, and this one's kind of thrown in there looking at some like word problems, some interesting things that you can do as far as modeling real life problems with functions. So if you look on your syllabus, you'll see, I think this starts on page 237 and goes through, the homework problems are on page 240. So it's basically at the end of chapter 2. Okay. So here's the question. Find a function that models the area of a circle in terms of its circumference. So the first thing I would probably do is just write out these formulas. So I know if I'm dealing with a circle, the area is pi r squared. The circumference is 2 pi r. So what I'm looking for is the area. Find a function that models the area of the circle. But right now, what I have is the area in terms of the radius. Okay, so if I want the area in terms of the circumference, what I have to do is replace r by c. So what I'm going to do is I'm going to start by solving this formula for r, and then I'm going to do a substitution. So r would be c over 2 pi. And then I'm going to take that and I'm going to substitute that in for the r in my area formula. So the r is equivalent to c over 2 pi. So what I did there, I did a substitution. And then let me just simplify it. Squaring the fraction, square the numerator, square the denominator. Then I should be able to cancel one factor of pi. Looks like c squared over 4 pi. So this is the area as a function of the circumference, because that's actually the variable here. See, pi is not a variable. Pi is a constant, right? So this is not the area as a function of pi. I already know what pi is. This is the area as a function of the variable c, which is what the original problem asked for. The height of a cylinder is 4 times its radius. Find a function that models the volume V in terms of the radius r. So I guess let me start by writing something out. The height is 4 times the radius, okay? Find a function that models the volume. Okay, so I need the formula for the volume of a cylinder. So that's pi r squared h. Okay, but I want this volume in terms of the radius. So if you look at the volume formula now, I have the radius in there, but this has 2 variables. So this is the volume in terms of the radius and the height. Okay, now again, I don't count pi. Pi is, excuse me, a constant, not a variable. So if I want that volume in terms of just the radius, I need to replace the h in there. Okay, and get just an r. So I can use this top equation. So if I solve for r is h divided by 4. And then again, let me see. So I'm thinking about this. I'm looking. So what I was going to say next as well, if I substitute that in for r, but then actually would I have what I want? So if I substitute that in, I'm actually going to have the volume in terms of h, volume in terms of the height. But if I want the volume in terms of the radius, well, actually, I don't even need to do that, do I? I would just substitute this in for h. So you have to look and see, well, what exactly is it the question is asking for? So if I substitute 4r in for h, so now I'm going to have the volume in terms of the radius. Okay, so the volume as a function of radius, let's put that 4 in the front, 4 pi r cubed. Not too bad. Two ships leave a port at the same time. Okay, one heads north. At 10 miles per hour. Okay, let's see, that's that boat. The other heads east at 12 miles per hour. So it's not to scale. Just drawing something in here to represent the information that's presented here. Find a function that models the distance between the ships. Okay, so I guess we're looking for that distance. In terms of the number of hours since they left the port. Okay, so let me see what I can do with that. So I guess I'm interested in modeling the distance between the ships. So let me start by saying, okay, well, what are the distances that each ship has traveled? Well, I mean, I have to start with something. So after t hours, boat 1 travels, well, he's going 10 miles an hour, right? So he goes 10 times the number of hours, right? And boat 2 travels, he's going 12 miles an hour, so 12 times the number of hours. So actually, what are actually the distances here? This distance would be 12 or 10t, and this distance would be 12t. So actually now I could use the Pythagorean theorem, because I'd be saying, okay, the distance of length of this leg is 10t. The length of this leg is 12t. Okay, equals the hypotenuse squared. So let me see. It's 100t squared, 144t squared. D squared is 244 t squared. So let me see, if I take the square root, can I do anything with 244? I think 244 is divisible by 4. Let's see. Distance is going to be positive. Let's see, 61. 4 times 61, did I get that right? Let's see, that's 120, 240, 244, I think so. Okay, so then I can break that up to root 61 times t. So then let me see if this is what I was asked for. I can see the variable here is t. Okay, so let's see what the question asked, find a function that models the distance in terms of the number of hours since they left the port. Oh, so that's what I have. I have the distance as a function of the time t. So then it says, use your formula to estimate the distance between the two ships after 2 hours. So that's the easy part. All I have to do is plug in the value of t that was given and then see if there's any simplifying. Okay, so I guess distance after 2 hours would be 4 times root 61. I have to put units. That would be miles. Let me put that on this one too, actually. Can include units even though I have formula here. Okay. And then, I mean, that's a nice exact answer. So if you wanted to, you could get an estimation. That part you wouldn't do on the test. That's a calculator problem, but maybe on the worksheet. 31.2 miles. That's a fun one. Find two positive numbers whose sum is 100, the sum of whose squares is a minimum. Find a function that models the sum of the squares in terms of one of the numbers. I mean, I have to just start with something. Let's see, two positive numbers whose sum is 100. Let me just start with something like that then. The sum of whose squares. So that means I square each number and add the 2. That's the sum of the squares. So I guess like that formula, that would be like the sum function. It's a function of both m and n. So the goal really is, the question here says, the sum of whose squares is a minimum. So like the idea here would be to minimize this function. But let's see what the rest of this says, because they're really not asking us to solve. It says, find a function that models the sum of the squares. Oh, there's that. But it says in terms of one of the numbers. So that means what I have to do is I have to get rid of either m or n. They want this just in terms of one of the numbers. So again, I'm going to do a substitution. So solve this first equation for either, let's see, therefore, for either m or n. Then I take that and I substitute it into the second formula. And then I guess I'll simplify it. So I have to do a FOIL, right? 100 minus n times itself. So what is that? 100 times 100. So I add 2 zeros. And then I'd have minus 100 minus another 100 minus 200n plus n squared plus another n squared. So this is the sum function as a function of the number n. So let me rearrange. I have 2n squared minus 200n plus 10,000. And then I think that's all we wanted. Find a function. Okay, so we don't actually have to solve the problem. Here's one that we've kind of dealt with before, but this one's looking at, you need to fence a 3-sided rectangular field with one side on a river. I think we've done that part before. Let's see, here's the river. Here's this three-sided field. Let's see what else it says. Okay, we've accounted for that. What else? The side opposite the river's fencing costs $6 a foot. Okay, so on this side, my fencing is $6 a foot. The rest is $4 a foot. So that means here I'm paying $4 a foot. The field has an area of 800 square feet. Okay, so the length times the width is 800. Counted for that. Find a function that models the cost of fencing the field. Okay, let me see if I can start with that. So the cost of fencing the field. Okay, I'm gonna have to pay for the fencing on this side. Well, it's $6 a foot times I'll need Y feet of fencing, right? So I'm gonna pay 6 times Y. Okay, what about the other two sides? I have two of them. Each side I'm gonna pay 4 times X, right? $4 a foot times X feet times there are two of those sides. Let me just simplify that one. So I've got 8x plus 6y. And then my other equation, xy equals 800. So I have like a little system here. Let me go back up to the question. Find a function that models the cost of fencing the field as a function of the length of the side opposite the river. So I want a function of y. That's the side opposite the river, huh? Okay, so I need to take my cost function, get rid of x. Okay, so what I'm going to do is a substitution again. So I'm going to take this bottom equation, solve it for x. Then I'm going to substitute that in the cost function. And then I guess I'd probably do an LCD. So I would multiply this by y over y. So I'd have 6,400 plus 6y squared all over y. And then there's the cost as a function of the side y, which is the side opposite to the river. These guys come up a lot in calculus. It's a good problem. That's the last one.